In this video, we're going to find x such that the cube of x squared plus 3x minus 4 plus the cube of 2x squared minus 5x plus 3 equals the cube of 3x squared minus 2x minus 1. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. There is actually a reason for me to arrange these expressions in this way. It's because that we can observe that if we add the x squared terms, then we'll have the sum at the right. If I add the x terms, 3x and minus 5x together, then we'll have minus 2x at the right side. And for the constant term, it behaves the same way. Minus 4 plus 3 equals minus 1. Now that means if I let a, b, c be these three quadratic expressions, say let a be this, and then let b equals 2x squared minus 5x plus 3, and let c equals 3x squared minus 2x minus 1, then we can say that actually we have a plus b equals c, and from our original equation, we can rewrite that as a cubed plus b cubed equals c cubed. So now we have two equations happening at the same time. And from this, I'm going to rewrite the equation on the sums as a plus b minus c equals 0. And in other words, a plus b plus negative c equals 0. So the sum of a, b, and negative c is 0. While for the equation about the sum of cubes, I'm going to rewrite that as a cubed plus b cubed minus c cubed equals 0. And I can say the sum of cubes of a, b, and minus c, not just their sum, but the sum of cubes is also 0. So now we have found three variables, a, b, and minus c, having both their sum and the sum of cubes to be equal to 0. Now at this point, we can recall a fact, which is an identity that says for any real number, actually it need not be even real, just three random numbers, p, q, r, we can factorize this expression, the sum of cubes minus 3 times the product, and we'll get the product of their sum and this expression, p squared plus q squared plus r squared minus pq minus qr minus pr. If you want to prove that this fact is true, you just have to expand the right side and simplify, but I'll just omit it in this video. Now to use this fact, we can just replace p, q, r by a, b, and minus c. And you can see that sum of cubes over here, sum of cubes, the green part is 0, sum at the right side, and it's also 0. So we can say that from the fact, we know 0 minus 3 times not PQR, but 3 times A, B times minus C equals 0 times some expression about A, B, and C. But that's not important because there's 0 times this expression, which is definitely 0. So we have 0 at the right side. Now that means 3A, B, C equals 0. And we have a, b, c equals 0, divided both sides by 3. And we know that if I have product of three numbers to be 0, then either one of them has to be 0. So either a equals 0, or b equals 0, or c equals 0. And at this point, we're actually not trying to solve for a, b, and c. We're actually trying to solve for x, and a, b, and c actually all each equal to some quadratic expression of x. Now, so at this point, it's just an elementary maths question at school. we have 3 quadratics. X squared plus 3x minus 4 equals 0. And then 2x squared minus 5x plus 3 equals 0. Or their sum, 3x squared minus 2x minus 1 equals 0. Now then we can factorize. It seems that all 3 quadratics contain the factor x minus 1. So then we can conclude that x is either 1 or, from each of the quadratics, one of minus 4 and the other is 3 over 2 and the last one is minus 1 over 3. If you put them all into the equation, you can see that they are valid solutions. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.